Okay, hello everybody, and welcome to the industry panel of the professional development. It's great to have you. So first, hi, I'm Mohammed. I'm a postdoctoral fellow in Kremble Center for Neuroinformatics, and I was the communication officer from last year. And today I'm joined by Jane Wang and John Cron, while we're waiting also for our other panelists. They're going to be joining us shortly. We can see them in the chat now. So let me first introduce our panelists. So first we have Jane Wang, who is a staff research scientist at DeepMind and is a member of the neuroscience team. And we also have John Cron, who's currently chief data scientist at the machine learning company Nebula. And he's also the author of the Deep Learning Illustrated book, which is like number one bestseller, and it was translated into 7 languages. And we also got Kevin now joining us. So yeah, Kevin is also a research scientist at Google. He's been there for 11 years now, and before that was an associate professor in University of British Columbia. And currently Caesar is also going to be joining us, so let me introduce him before going on camera. He's a neurodata scientist currently at Synchron, and before also was at Catalyst Neuro, and was a visiting fellow at Harvard University. Okay, so how about we start by each panelist, maybe adding a little bit more depth to this very quick introduction, and also telling us about their stories, about how they came to reach where they are, and their stories of like leaving academia, etc. So should we start with the last person to join so far? Let's start with Kevin.
Yeah, sure. I grew up in the UK, did my undergrad there, and came to the US for graduate school. And then after I finished my PhD, I went to Canada. I was a professor for about 8 years in CS and stats. And then I came to Google on my sabbatical. That's a very dangerous move because Google is a very sticky place. I came in 2012, I guess. 2011, I should forget the timeline. And machine learning was starting to really heat up. And I also really liked living in the Bay Area, so I decided to stay. And that's how I ended up at Google, and I've been there ever since.
Nice, thank you. So let's go with Jane now.
So I kind of started off in neuroscience, doing a PhD at Michigan in applied physics and computational neuroscience, before doing a postdoc at Northwestern, going more into cognitive neuroscience. And from there, I joined the experimental neuroscience group at DeepMind, and
No, we're losing the connection with Jane. Let's see.
Oh,
okay.
Sorry.
Back.
Is it back?
Yeah.
Okay. Should I finish, or I don't know how much got cut off?
You've gone to cognitive neuroscience.
At DeepMind.
Okay. I was pretty much done. So then, from there I just got progressively more into AI and machine learning at DeepMind. Yeah, been here for about almost 7 years.
All right, thank you, and welcome Caesar on screen. Good to have you. Okay, so
hi.
Until you, hi, yeah, you go on if you're settled already.
Yeah, I'm settled. I just had trouble with the camera. So that great to be here. So as everyone knows, I'm a data scientist I started my neuroscience career in undergrad. I went to MIT and I started doing research in a computational neuroscience lab, studying the visual function of or like how the cortex processes visual information. I went on to do that during my PhD, and at some point during my PhD, I kind of grew less and less satisfied with the idea of basic research, and I found that I wanted to do something where we apply the knowledge that we have from neuroscience and the general machine learning towards creating new technology. So I've been at Synchron for 5 months, where I'm working on creating devices that translate brain signals into commands to a digital device. That's a little bit about me.
Great, thank you. So, how about you, John?
Nice. So my name doesn't rhyme, so that is a common mistake. So Mohammed introduced me as John Cron, but I'm John Crone. I do have an Aunt Joan, and her name rhymes. That's not made up. So I, like Jane, did a neuroscience PhD. I did mine at Oxford, and during that time, I created a startup based on some of my research during my PhD. I was looking for funding for it in New York. And while I was doing that, I met some folks that were starting a hedge fund, and I really liked what they were doing. They were looking for somebody with the machine learning background that I had. And so I joined a hedge fund for a couple of years, and I found that horribly boring. So working in finance, particularly as a trader, even though we were doing some of the cooler kind of stuff in that space where you're creating machine learning algorithms that are doing automated trading, in our case on a sub-second scale, which is theoretically exciting, but it's not. If you spend your life solving interesting problems I know a lot of people in Neuromatch are interested in neuroscience, and there are such interesting problems out there to be solving in science. Once your life becomes predicting whether a given asset is going to move up or move down for the next few seconds or the next few months, it doesn't matter. Predicting whether an asset is going to move up or down, I think, is incredibly boring. And if anybody out there is thinking of going into finance, my number one piece of advice is stop thinking about that. So that was, I was interested in, similar to what Caesar was saying, I was interested in applications, not just basic research. I wanted the work that I was doing to be making a tangible impact on people. I thought going into industry would scratch that itch, but I think going from academia to being a trader at a hedge fund was the pendulum swinging too far. So I've since 2014, I've been a data scientist. Since 2015, I've been the chief data scientist at a machine learning company. It used to be called Untapped. We were acquired after 5 years. And now I've co-founded a new machine learning company called Nebula. Very quickly, whether we're talking about that previous company Untapped or the current company Nebula, my specialization is creating machine learning algorithms that allow us to automate aspects of business processes, particularly in human resources and recruiting.
Great, thank you. So we have here the panel is consisting of people who've actually did the transition from from long time ago until some that are more recent. So I actually wanted to ask Kevin especially, how was it this transition, and why did you decide to move at the time? How was it different from the scene now? And if you would have returned, if you would have to do the same decision again, would you have done it?
Oh gosh. Well, I mean, I was super happy in academia, but when I came on my sabbatical to Google, I sort of sensed that there was new opportunities, right? Particularly to do, to have practical impact and to do things at scale. And there were, personal factors in my life that made living in the Bay Area preferable in some ways. So there are a variety of things. So I took a leave of absence, as many professors do, and to sort of hedge my bets. And then my employing university, UBC, said, okay, well, you have to make a decision. So at the time, I think it was 2011 actually. So I guess people usually say the deep learning revolution started in 2012. So this is just before the revolution was about to sort of take off. And I actually wasn't really doing deep learning. I was a little skeptical in the early days. I was doing graphical modeling. I think some of you may know my work in that area. And I was interested in unsupervised learning and learning from video. And I realized that's computationally quite expensive, and that industry would have an edge in that space. So it's a bit of a gamble, but I would say it's a gamble I took that paid off big time in many ways. So in hindsight, I would have made the same decision. Now I have more information confirming that it was the right choice. But I'm not casting shade on academia or academics. We need them, and there are certainly aspects of that I miss for sure. Teaching and research freedom and so on and so forth. But I'm very fortunate that I'm in an industry lab that supports basic research, lets me work with students, and attend events like this. So I still feel like I'm a quasi academic. I kind of have the best of both worlds. So I consider myself quite fortunate.
Great, thank you. Yeah, so I actually have more questions, but I want to give more to the audience questions. So maybe let's start with the highest voted question so far. So it's come from Nilesh, and it says how much preparation needs to be done to get a research scientist job at DeepMind, Facebook, OpenAI after completing masters. So does anyone have can just have an answer to that and want to take a shot?
I mean, I can say something initially, and maybe Jane can say something from her perspective. Typically, research scientists have PhDs and often postdoc experience as well, so they're already very highly qualified. An entry-level research scientist position at Google or Facebook or wherever is often considered on a par to an entry-level assistant professor position. So you need to be in that ballpark. Now, there are research engineering positions that might put less stress on publications and research record and more stress on coding skills and having a strong GitHub portfolio and so on. I don't want to say it's easier, it's just a different set of skills that are emphasized. So yeah, I think the bar is quite high for those kinds of positions. There are fewer research scientist positions than there are research software engineer positions, and then there are fewer of those than there are just sort of mainstream software development person, right? Because if you're a general purpose engineer, then you could work on multiple projects. It's a pyramid, right? There's many more people needed to ship an Android project or product or do something in ads than there are to fine tune a transformer on ImageNet, whatever, which anyone can do. Everyone is doing, right? It doesn't take that many people to do that, but to really make it robust and real time and not suffer from many of the flaws that you encounter when you do things in production, that takes a lot of people with a lot of effort, and therefore there are more opportunities there.
Great, thank you. So anyone to add something?
Yeah, I can also add from my experience at DeepMind. I agree with most of what Kevin said, but I wouldn't say that it's necessarily as high of a bar, at least in my experience, of assistant professorships. Or maybe that's just because there are so many, there's actually a lot of really qualified people that just out of PhD would, at least in machine learning, would immediately be able to get an assistant professorship or something like that. So I guess I know a lot of research scientists who have joined DeepMind directly from their PhD. So don't usually have postdoc experience. They're really sort of sought after, I guess. They could have their choice of either going the academia route or joining some kind of position with the place like DeepMind or Google. But I will say that it's So it's not really like you're an assistant professor. I would say, especially entry-level research scientists at a place like DeepMind, you are more of like a high-level postdoc, like starting out. And their career path is not the same. So you're not in the end going to end up sort of like in this, like with an assistant or like an associate professor type of role where you have your own lab and you sort of have your own team. I mean, there are team leads, but the vast majority of research scientists are sort of more independent contributors, and you're working in a very collaborative style, right? Where you're not like sort of advising or mentoring a bunch of students or other people on your team. Because even if you do have a team, you know, you're leading a team of highly qualified experts, and so they're sort of focused and interested in their own specific projects, and you're kind of more guiding them. So that's just kind of like a difference between academia that I've found.
Great. So Caesar or John, anything to add?
Yeah, sure. I mean, I guess I'll talk a little bit about the transition from academia, since it's more recent for me, which is pretty much, I feel like I'm doing the same things I was doing as a grad student, like applying machine learning methods to neural data is what I do now. I guess that's just specific to the industry I'm at. Yeah, and I mean, I feel like even like at least for these types of jobs, we're usually looking for people that have, you know, neuroscience PhD, because we care about the fact that you have understanding of the underlying data, which is neural data, and the processes that generate it. So we're looking for people with neuroscience PhDs and often, you know, postdoc experience. These are like the people that are on my team.
Excellent. Any 2 cents?
Nice. And then I don't have a specific advice related to those particular firms like DeepMind or OpenAI. I haven't worked at those firms, and I haven't been particularly interested in working at them myself. One thing that I could recommend is, so I host the most listened to podcast in the data science industry called Super Data Science. And on the program, we have lots of people who are doing research at firms like that. And so I think that if you're interested in doing that kind of work, listening to a podcast like my Super Data Science show or other programs can give you a good sense of what the work is like in those kinds of companies, and whether it is, whether that is a rev that you want to go down, or whether there's something else that you might want to consider, like working in a small startup or maybe even staying in academia.
Excellent. Thank you. So maybe let's move to the next highest question. So here's by, I'm not sure if I'm pronouncing the name correctly, but Mnugank. What kind of industry options would you suggest for someone doing PhD in cognitive neuroscience, either for internship or jobs after PhD? So I think this is more a question maybe for Caesar.
Yeah, I would say, I would say it depends on what kind of, I guess cognitive neuroscience is such a broad field. Are you working with more behavioral data, or are you working more with, electrophysiological recordings, that kind of stuff? Because if you're working with electrophysiological recordings, brain-computer interface and just neurotech in general is a great field to get into, and it's growing. If you have more experience with behavioral data, then something like user research, UX research experience is like a good it's a good thing to get into, and the skills are very well transferable. Yeah, I guess that's what I have.
Thank you. So, Jane, you also come from, you're working in neuroscience, so what's your opinion?
Yeah, I mean, it's kind of a hard question, right? Because it really depends on what skill sets you have really focused on in your cognitive neuroscience PhD. Because it's more about just figuring out a way that you can translate those skill sets into something that would be attractive for somebody, or for an industry or a corporation or something like that. So I had to really, I mean, I was looking at a bunch of different places when I decided to leave academia, one of which was I think Sandia National Labs has a sort of like neuroscience or AI-ish, like cognitive, like I guess maybe cognitive science division. And I was looking at other and then like AI, like Allen Brain Institute also had, was like hiring. So I think for each of those, I had to kind of tailor the specific work that I had done to fit maybe what it seemed like their current like priorities were at that time. And so, yeah, I think it's really about just learning how to recognize what are the skills that you picked up, because just having a PhD in cognitive neuroscience is not going to like get you in the door for a lot of these corporations. It's more about figuring out how can you like fit your skill set to be attractive to them.
Yeah, I guess I would add to that quickly, and this is without, so as the previous answers have kind of alluded to, having a PhD in cognitive neuroscience doesn't tell us a lot about you necessarily and what you're interested in, and that's going to drive a lot of what you want to be doing with your career. To give it's what you decide to do next has a lot to do with you, not so much with the degree name that you have. And so to just plug something that I am hugely biased towards that you might want to consider is when you're fresh out of a PhD, you typically have, you're at a point in your career where you could be taking more risks than potentially later in your career. So as you get more embedded in your career onto a particular trajectory, or maybe with obligations to dependents like partners or children, as those kinds of parts of your life kind of ossify, it's harder to take risks. So if you have any inclination post PhD to be doing something that is high risk but potentially very high reward, and also high impact, is getting involved in early stage startups or even mid stage startups. So this could potentially be starting your own, which is the riskiest and most stressful of all, but also potentially the most rewarding, or getting involved in early stage startups. And so if during your cognitive neuroscience degree, you happen to be specializing in machine learning techniques, in deep learning techniques, like you are likely to be if you're here at Neuromatch Academy, then there are lots of startups and lots of venture capital firms that would be interested in hearing ideas you might have or ways that you might like to be involved. And typically those kinds of opportunities, they will pay less in terms of cash for the first few years relative to, say, DeepMind or OpenAI, but you can get a large equity stake and you can learn a lot about commercializing technologies and having those make an impact, which over the course of your career can mean many, many multiples of what you would be getting in salary at kind of the more comfortable established firms.
Thank you. So before I move to Kevin, there is like a follow-up comment talking about, I think, answering to Caesar's question, doing EEG, fMRI, and TMS as of now.
Yeah, so maybe doing something with neurotechnology might be a good potential thing to look into. Yeah, these are usually like to smaller companies just because it's a relatively young field. So you got the chance to get into, as John was saying, you can get the chance to go into smaller companies, and you get to see how technology that's at the cutting edge, how it's developed, and the challenges that people face and how they surmount them.
Okay. Kevin, do you have something to add? I know you come from computer science, then not really neuroscience, but...
Yeah, I feel like a bit of an outlier in this crowd. I do have a little story to tell. So I'm not sure how the Neuromatch people chose me to invite me. But the reason I accepted is that my son has actually been taking some of the Neuromatch Academy materials. He did a internship this summer with Scott Lindemann, who some of you may know, who's a stats neuroscience professor at Stanford. I don't think he's in this call, but I saw him in the other panel. Anyway, I felt like it would be good to give back because my son has benefited from the education material that some of you guys have put together. And I did take some, I think like many people in AI, I have an interest in neuroscience and psychology and cognitive science, but generally, although I don't have any professional expertise in it, I took a couple of subject classes on it in graduate school, actually from Eero Siemencelli, who I'm sure some of you know as well, when I was at Penn. So I sort of have some tangential connections, but I have no good advice on people who are studying it for real because I'm an outsider.
Yeah, so actually, because this is like the deep learning school panel, so, we are really interested to have, people from the deep learning world, not necessarily neuroscience, but given how Neuromatch started with a computational neuroscience, so you would expect to have like more audience from the neuroscience background.
Yeah, it wasn't clear to me. I guess you have two offerings now, right?
Yeah.
Like it seems like basics of data science for the neural data analysis, and then the deep learning thing. So it seems like there's a grow the
computational neuroscience school and deep learning. Yeah. So this panel is more for the deep learning audience. Alrighty, so let's get to another question. So from Louisa. And asking, do you have any tips for undergrad students who want to pursue research position in industry? And what would be more productive in this case, try to publish paper or getting regular software engineering internship? Yeah, I think like the first part we probably has touched on, but maybe like let's comment more on the second part. Like, do you think it's better if it's more publishing or more programming expertise?
Well, I think definitely publishing would be what we would be looking for, especially for a research position. I guess if you're going for more of a research engineering role, the engineering might help, but research is still sort of the number one, or like publications is sort of the number one signal that we look for, at least with full-time hires. But I am noticing like a common theme in all of these questions. That's kind of just like trying to get a job at these companies. And I guess I just want to say one thing about it's not just about like making it a goal to get a job at like in industry or at one of these companies. It's about knowing what your story is and what really excites you, and why did you go into neuroscience, and why did you now, or what concurrent with deep learning, or like what has been your trajectory, what has led you to find these fields interesting and fascinating, because this is going to be what the interviewers are going to want to know when when you're talking to them, is like, do you have a deep a passion for these kinds of questions? If you're going to be a researcher, what kinds of questions are you going to be asking? And so I think it's just more about like kind of knowing your own interests and figuring out what is your story, and that's what's going to, I think, help you out a lot when you're when you're trying to find a job in industry research.
Yeah, I agree. And I feel, like as someone who's like, trying to fluctuate between like the computational neuroscience and AI myself, yeah, I find it's like just finding what you actually want to do. This something actually takes time and a lot of, experimenting and thinking. Okay, so how about you, Kevin? Because you say you have to leave early, so yeah, please.
I don't think my son's ready to sub in yet. He's only 17. He's just starting. But in terms of internships, I think if you're applying for a research internship, then papers are the currency of the realm. But most papers, and there are some pure theory papers, but even pure theory papers usually have experiments. And the majority of papers are highly experimental in the deep learning field. And it's good practice to open source your code, and people will look at it. And if your code is clean, that is a very significant bonus that you have. And I'll repeat what I said before. Right? There are many more positions. Your goal, it depends on what your goal is, right? If your goal is just to get employed by one of these big companies, there are many more openings in engineering roles than research roles. And then your coding skills will be the only thing that matters. They don't care if you publish. They want to know, okay, show me your code. I think if you apply for a research position, if it's, if you've got some fancy user interface, they might not care. But if there's some cool idea that you came up with, and then the user interface sort of illustrates it, that's like the best of both worlds, right? So you've got your code and you've got scientific novelty, and ideally it's applied to some problem that matters.
Excellent, thank you.
But yeah, I think work on your. I'm actually giving this advice to my son. Like work on your GitHub portfolio. I mean, he's just created one, right? But like that is a way to put things that aren't necessarily published. You can put things on archive. I mean, don't put random stuff on, but archive is a way to have things available to others that might not have gone through a conference reviewing process. Or workshops are quite good. Like getting published in conferences is super hard. I'm sure many of you have tried and have, we all get rejected. I still get rejected. Like people are complaining about this all the time on Twitter. It's a high variance thing. Don't take it personally. Like just do good work. Try to get it, verified by someone so that you've got a second pair of eyes, if only on the reading style, but also on the ideas. And then, keep moving. Just it's a long game.
Excellent, thank you. And yeah, also, like in case you have to leave at any moment, so thank you for your input in this session, and yeah, good luck to your son. Hope he or she is enjoying the session, the neuromatch.
Thank you.
Okay, so John, what's your...
I think we've covered this question enough.
Okay.
I think that we've already covered it earlier in people's responses, and I don't have anything else to add.
And I'm assuming the same for Caesar, or do you have something to add?
Yeah, I don't have anything to add.
All right, thank you. So let me see. So I think that we have a question about internships. So so the question is also things about how to get an internship. But yeah, I think it's how valuable. Actually, I want to make it a little bit more broad. So how valuable are internships? And basically, is it a good way for people to enter into a company by starting it with an internship, and also is there are they high selection, or what is the best portfolio to, for example, apply as an intern?
So I think internships are invaluable for figuring out what's important to you. So if you are currently a student, whether you're an undergrad or a postgrad, if you could do a wide variety of different kinds of internships, I think that is the most valuable thing for you in terms of figuring out what works for you. So try getting an internship at one of these big companies. Try getting an internship at a small company. Maybe do an internship in some kind of public research body. There are lots of different kinds of environments that you could be doing internships in. And so use the opportunity that you have now to be trying out these different kinds of environments and seeing what fits for you. And then in terms of what you need to be getting these jobs, I think that whether it's an internship or a full-time role later on, echoing something that Kevin said just before he dropped off, is developing your public portfolio. And so this can be, he talked about archive papers, he talked about GitHub. When you're talking about GitHub, I highly recommend that you are coming up with your own project so that you can speak to that really well. So Jane talked about being able to describe yourself in interviews and who you are and what your path is. If you have your own projects where you came up with the project idea, you collected the data yourself, you came up with the modeling approach, you have an explanation of why you got the particular results you did and what your next steps would be if you spend more time on this kind of project. By doing that, ideally, if you can do that in a few different kinds of applications, maybe do one in machine vision, one in natural language processing, one in deep reinforcement learning, so that you have a broad set of projects that demonstrate your interest in machine learning, in deep learning, and that show that you have the drive and the determination to be coming up with your own project ideas and executing them yourselves, which is ultimately what I am always hiring for. And I think most people are hiring for. Nobody wants to be babysitting their employees. When you're getting it, the kinds of jobs that all of you are talking about, these machine learning roles, especially the research roles that you're talking about, you have to demonstrate your independence because nobody wants to be micromanaging anything that you're doing.
Thank you. All right, Caesar.
Yeah, I'm gonna reiterate what John said. You know, do internships at all sorts of companies. I guess most people, I imagine here, have mostly been in school their whole lives, and what you don't realize is that you're only aware of a small slice of the world. And then once you go into any sort of experience in industry, you'll realize that the world's much bigger than you imagined. And having this sort of experience, you'll be able to connect with people that have different backgrounds, and you'll be able to see the many ways in which people craft their careers, right? So you won't only learn technical skills and build your portfolio, but you'll just acquire this intangible knowledge that there's no way you're gonna get it from a book or a course online.
Excellent, thank you. Jane, do you have something to add?
I agree with everything that's been said so far, and I think that having an internship at a company definitely helps if you want to eventually get a full-time position there. Not only because they already have a good signal that you are like somebody, like if you demonstrate that you're good to work with, but also that you would then already start to build those connections and collaborations that would set a good foundation for a career there. So but I also think I agree very much that internships are great opportunities to see what it's like to work at a company, to work in a particular role, to work with particular people, and that's something you can't get just from talking to people or externally.
All right, thank you. So let's move on to something that is a little bit different arc than finding internships and finding a job. So there we have this question is how do you keep up with the super fast pace in the field?
It is definitely like trying to drink from a fire hose. Yeah, with archive papers coming out like every single day. I honestly rely a lot on my Twitter feed, and that sounds pretty bad, but it's such a great like curator of all of this massive amounts of like new work that's being done. That is just sort of like rises up. But also we have internally, we use in our internal company chat, a lot of people will share papers that are that have come out that are really relevant, and and so I think it's just like more through word of mouth as opposed to trying to read every single paper that comes out every day. I think that's just impossible. Even the ones that are flagged on Twitter, I'll usually read like the tweet thread. If there's a tweet thread, I think those are really nice because it's like a nice, concise summary. And if that's interesting, I'll read the abstract. And then if that's interesting, I'll actually maybe like scan through the paper. But yeah, you really have to be like really strategic with your time, just because there's only so many hours in a day. You want to still be doing actual work and research. I know that keeping on top of the literature is part of our jobs, but you can't just be reading papers 24/7. So you have to really decide, what is the important paper that maybe like you have to wait a month before you read a paper, right? To see if it's like actually has staying power and has not been already superseded by another better paper, the next week. So.
Yeah, I keep hearing everyone saying like I follow papers on Twitter and that's a bad thing. So I think we need to establish, that it's not a bad thing anymore because everyone's doing it now. What about you, John and Caesar? Do you have any other?
Yeah, I don't have too much else to add to what Jane said. I think that her point about waiting to see if something has lasting power is a lot better than trying to keep up on the papers that are coming out every day. So the big papers, like they're going to be talked about, whether it's in Twitter groups or it's on Hacker News. That's another really good one. So the Y Combinator Hacker News is a great place for having the most important new research, new big breakthroughs in machine learning and deep learning. They end up on the front page of Hacker News. There's good YouTube channels. There's 2-minute papers on YouTube. He does a good job of summarizing the most impactful papers on new machine learning and deep learning research. And I think podcasts can be okay too, like my show, if you like an audio format in some cases as well.
I think Jack Clark also has a nice newsletter that he puts out every week, which I subscribe to. So it sort of like summarizes the top 3 papers of the week or something. It's pretty nice. Sorry, I cut you off.
No, it's all right. I guess I was gonna say, I echo the Twitter sentiment, or just like from one's own network. Let that curate what sort of captures your attention. Also, if I know names of people whose research I highly value, and there's like a way for me to go see them give a talk, I guess that's the gift of COVID, is like all of a sudden there's all these online seminars, right? So usually I'll opt to like go and maybe hear like the summary from their talk about their work at large, and then decide, is there something specific that I want to dig more into.
Excellent, thank you. So also there's this other question, which is like, what is your the recent AI research that is not related to your work but still that excites you the most? I like this question.
Sorry, repeat that question.
What is the recent AI research are you most excited about that is not directly related to your own work?
Well, this is probably a very common answer, but all of like the new text to vision generation, DALL-E 2, Imagine. I think there's another one that's recently come out too. I can't even keep track, but they're, I don't work on image generation directly, but it's, I just think it's become kind of like a sea change in terms of how we think about the capabilities of these models. Just like I don't think that we were necessarily expecting to see the kinds of creativity and compositionality that they're showing. And there's now new interest in trying to understand how they're doing that. So we're at, I'm seeing people like trying to treat them like they're using neuroscience techniques to study them as if they're model organisms, and to try and see like, well, what are they actually capable of, and to apply different kinds of tasks to them. So I think that that's actually really exciting. So I'm excited to see what's going to happen with that.
Yeah, 100%. I mean, the foundation models in general. So the text-to-image models that Jane just described, or the natural language models in general, these foundation models that have been growing exponentially in recent years, with models like Wudao 2.0 and the forthcoming GPT-4. I think we're going to continue to see pretty remarkable improvements in what's possible, sheerly through brute strength, which is something that I don't think people were anticipating. But it looks like now for the next several years, we're going to see big jumps in model capabilities through parameter size alone. The downside to this, to me personally, is that up until the last few years, it was possible for me to have a relatively simple GPU server at home or in my office on which I could train or fine-tune models that were comparable or equal to leading deep learning models. And now, that's no longer possible. Now, the biggest, even a couple of years ago, like GPT-3, cost millions of dollars to train, and the models that are going to be coming out in the years to come, they'll be tens of millions or possibly orders of magnitude more to train. And so on the one hand, I think it's super exciting to see the outcomes of these huge foundation models. On the other hand, it's kind of sad to be able to lose having control over being able to yourself hold in your hands almost the most powerful models on the planet.
Yeah, we have is saying that the new Deep Nash model used about 1,000 TPUs. What about you, Caesar? What's the AI that excites you?
I guess same thing. The DALL-E is something that I guess just grabs the imagination, and it's easy to see, the power of it. I guess one thing that Jane alluded to is a line of research that I find really interesting is the people that are looking at sort of explainable AI, like places like Anthropic that are trying to once you train a model, trying to understand what are the rules that the model is developing to solve a specific task. I think just the general strain of explainable AI is really interesting and sort of crucial to gain for the systems to gain trust and gain wider adoption. I think that's sometimes that's a barrier to adopting any cutting edge technology. It's just people don't understand it, and so they don't quite trust it, and sometimes they'll opt for something that maybe doesn't perform as well, but at least they understand it. So I think that's a interesting field of research to keep track of.
Excellent, thank you. So here's one thing that is also, I hope the answer is not also DALL-E, but let's say in computer vision, like what do you see the next big thing in there? And also what is like the goal that remains to be achieved?
I don't really have anything specific to add on that.
That's outside my expertise, so I'm not sure what the state of the art in computer vision is.
I mean, are you talking about computer vision like generation or classification or?
I think in general, yeah.
ImageNet, or I mean, because I think the biggest thing recently is like diffusion models, right? But those are still generative. I guess, yeah. I mean, I think that I'm not a computer vision person, but I tend to get a little bit bored with like constant ImageNet performance, bumps. So I feel like people are moving more towards using these models in other models, right? Like maybe people feel like we just solved the classification problem at this point, and now we want to like do something useful with it, like self-driving cars or putting it into an agent. I think that it's really, now we're trying to understand what are the important features that maybe we should be using for planning, or how much, like what level should we be doing planning at? Should it, like, do we need a good visual feature encoder first, or can we get away with something a bit more abstract or something? So
I personally think, the next thing is, getting something that is as robust as the human being brain without having that much parameters, which is, I mean, there is a little bit of work, especially on like this feedback models as well, but yeah, it's still not very advanced, and I think a lot of people have added feedback, but nothing is still like working really well. So yeah, that's actually one thing that I think in computer vision would be really interesting to have. Alright, so we have only like 7.5 minutes left, so I want to get like something that is a little bit more higher level. So I would like to ask, like, relating to the question of like, or to the, like what Kevin was talking about, how much of the sizes of the models, and how would you think about the idea of the impact of the size of the models on like climate change and things such as like, are we going to keep expanding without regards to like the footprints of this machine learning training, or should there be like more work, or is there enough work on this field of like, how to decrease the carbon footprint of the AI and deep learning in particular?
Yeah, I think this is a really important issue. I know that some of the companies that build these very large models do them in facilities that are carbon neutral, and so that is part of the solution. I also think that there's a role that deep learning, machine learning in general, can play in mitigating climate change. And so I don't think that we should stop building bigger and bigger models because of climate change issues. I think that it's a situation of having the data centers be carbon neutral, and it seems like the big players building these big models are largely moving in that direction.
So yeah, I think this is a very important consideration, that if you are building one of these big models, that it is something that should be kept in mind. I think for me personally, I am really interested in the idea of not thinking about these models as being like a learning algorithm, but as actually an artifact that once sort of you trained, then you just have this model that you can use and you can play with, like, you know, the OpenAI, their GPT API. But also thinking about, like, well, how can we maybe try and use pre-trained modules, or to see if we can move more into the field of looking at continual learning, or like not having to train completely from scratch for every single paper. You know, this does like run into issues with maybe you can argue like replicability, right? Like maybe we need to reproduce from the beginning every single experiment. But I guess that's really, you know, a question of like what your goal is, right? If your goal is to say, oh, I can scientifically prove that I can make this kind of a model, then that's sort of one goal. But I think that maybe AI has much more of an engineering goal than maybe like the strict like classical sciences, where a lot of the field is trying to just create something really smart and like create new technology that can better people's lives, and so that might require, you know, rethinking the way that we think about writing papers or conducting experiments and needing to sort of do everything completely from scratch, which is very energy intensive.
Great, thank you. And Caesar?
Yeah, I don't have much to add. I think it's been covered.
Excellent. All right, so now I think we want to close the session. So before that, like, any parting, you know, advice or thoughts to students, or, you know, words of wisdom from each one of you here?
I saw Caesar take his mic off. Caesar, do you want to go first?
Yeah, sure. I'll go first. I guess my advice is just, you know, talk to as many people as possible, ask as many questions as possible. You know, just expose yourself to different ideas, and if something excites you, just go down the rabbit hole. Don't overthink it too much.
Excellent. Thank you.
I guess I would just reiterate what I said earlier about really thinking through your story and making sure that you know what you're about and what your journey is. It might seem that you've, you know, like, at least for me, if you just kind of look at my resume, it looks like I just sort of veered from one career to another, you know, neuroscience, like physics to neuroscience to AI. But when I go back through it all and I trace through the reason why I did, you know, make those career shifts, it does make sense narratively, and it like leads to overall my interest in creating intelligence and in thinking about how intelligence works. So yeah, I guess just, you know, spend some time really thinking about that and being able to talk about it with others in a way that, you know, conveys your passion for it. So I think that people would really respond to that.
Nice. That is an awesome tip, Jane, and also yours was great, Caesar. I would add that I highly recommend you make as many connections as you can. You stay engaged in the community. So all of the great opportunities that I've had in my career, whether that's some opportunity in academia or in industry, or even people that have worked for me who have been amazing people that I've been able to hire, all of the most wonderful things that have happened in my career happened through making connections. So you don't need to think about this as like formal networking, which is kind of cringy, but through things like NeuroMatch, I think that that's a great way to go. Meeting people online is great. I also encourage you to be making strides to be meeting people in person. So this might vary a little bit regionally, but in the United States, for example, meetup.com has great local meetups, which are starting to happen again post-pandemic. And these are amazing forums to continue to build a network of people that you just never know what conversations you might have with them that will spur your interest in some new paper, some new book, or some new career opportunity that you would never have thought of without having that conversation. And personally, I'm just super biased towards in-person interactions because I think it just makes life a lot more fun.
Excellent. Thanks for those parting notes. Like, we're ending at a high note here, and so first I would like to thank everyone, all of our panelists, and everyone who's in the attendance for this great session. And I think all of the panelists have put their Twitter tags in the chat. So if you want to follow them or send them a message.
On that note, quickly, so I do use Twitter, but my biggest social medium is LinkedIn. And so I put my LinkedIn in the chat as well. And I highly encourage you, anybody who's been here in this panel, if you add me on LinkedIn and put in the connection message that you were here in the NeuroMatch session, I will accept it for sure. And would be really happy to connect with you. As I mentioned in the chat, the best way to ask me questions is to ask them in public posts. I don't have time to answer all the individual messages that come to me, but if you do it as a public post, and I will make the time to answer it for sure, and then other people can benefit from the response, and maybe they can add to the response as well.
Excellent. Thank you very much. That's really great. Yeah, so please, for the audience, please join me in thanking our panelists, and check them out on social media, and also check John's blog and podcasts, and his book also. And great to have you, and hope to see you in the next session.
Thank you for organizing.
Thank you.
For a great session. Bye.
Yeah, thanks.
Bye.
Bye.